Dear students, so the first article which we were discussing about was a machine learning based sustainable university field training framework for higher education. So, as we know that we make a framework in which we were taking the formative and summative assessment from academia's trainers and from the trainers from industry. So the inputs or the rubrics from the industries were taken as a considered as a formative, and the rubrics from the teacher was considered as a summative. So in this the purpose of this research was to have a minimal portfolio errors and minimal manual interventions. And the second most important purpose of this research is to align the practices, the university practices with the accreditation body, the ABIT. Here we developed, we applied three different algorithms, data mining algorithms, that is the naive-based algorithm, J45, J48 decision tree, and part algorithm. So naive-based algorithms was outperforming, and it resulted in a 90.5%, 54%, while the J48 and part was lower, and it gives result of 87%. This is the generic framework we have it, which starts with the course portfolio, and it is divided into summative, formative, and then with the number of years, course and semester. And then rubrics are further divided into three different categories as introduced, reinforced, and emphasized. And then for knowledge discovery, we divide into three: data mining and machine learning, data visualization and reporting. And the performance indicators are further divided with respect to the course instructors input and the industry partner inputs. And then we see the continuous improvement with respect to the ABIT accreditations. So since data preparation takes a lot of time, and the data set is hypothetically divided into different parts, the input from the coordinators and from the supervisor. The different four kind of rubrics are divided or categorized. The rubrics are basically categorized into four parts: the non-existence one or the poor one from 0 to 24, developing 25 to 49, developed is 50 to 74, in exemplary 75 to 100%. Okay, so the tool which we use was Weka from Waikato University, New Zealand. Okay, so we divided the training into two, our experiment into two parts: the training and the testing. Some of the people, they do into three parts, along with the validation to see the underfitting and overfitting. And we got different results with respect to correct classification, capacity statistics, and the time executions of that one, and reliability. So I will show you the results here. In this one, we have all these results. So if you see over here, Neves base was performed very good, and it was 90.5%, and couple statistics are also higher, and with the minimal time. The other are support vector machine and logistic regression. They perform lower with respect to couple statistics and classification. If you go back to this one, then just to to analyze the results more. So we found the sensitivity recall, which is true positive over true positive plus false negative. Specificity, as we know that true negative divided by the true negative plus false positive. Precision, it is achieved through true positive divided by true positive plus false positive. And then we have F1 score. F1 score is the harmonic mean. So if we divide that precision over the recall, we get F1 score. And it is utilized to as a weighted average accuracy and the recall, right? So these three would be used over here. So I will be giving example here, diagrammatically, what is precision? So precision means how many retrieve items are relevant, right? So that is precision. But if you look at the recall, so how many relevant items are retrieved? So the context is different over here. So these are the rubrics which we use in our experimentations for summative assessment. So the generic summative assessment, these are like, 5 different, summative assessment rubrics we have it. And then these rubrics are aligned or with the Abbott accreditation. So the rubrics are aligned with the assessment. So R1 with the S1, so R2 with the S2, R3 with the S5. So S5 is connected with the R3 and R4. S2 is connected with R2 and R5. And similarly, you can also notice the other one. So let's suppose what is the first connection: dependability and reliability. The second was ability to learn and search for information. These are the different ready-made rubrics from the Abbott accreditations. And then this one we have assume industry training data for the student progress. So from the trainer side, when the students go to the industry and they do training, so what are the rubrics they have? So we consider the attendance, which I would like to highlight here. This is the attendance of the students. Some have 82%, some have like 91%. These are different certificates they achieve while they do training, and these are the different rubrics: R1, R2, R3, R4, and R5 with respect to their characteristics, what they do in the industry in front of the tasks assigned to the students. While these are instructors data progress, for example, what is their GPA in the college, what is their previous GPA, and what are the different rubrics while they were studying with instructors at the university level. So this is the two tables. This table is about the different report. This is also about the GPAs and examiner's report rubrics. So these are the different examiner reports when they are doing presentations. And this one, table 6, is about the examiner presentation rubrics as well. Okay, and these were the examiner reports for the table 5 is basically about the reports which they submit to the teachers, what they are doing frequently. Like for example, maybe there's a one report in or two reports in a month. So total are mostly 3 reports. Students data on the industry training. So what are they doing in the industry training? So this is the data related to the students with the industry training. Yeah, this one I already explained with you that how our algorithm works, and news base was the outperforming one. This is more about mean value and standard deviations, and if you look at here, this one is a precision value, right? So the first one is a precision value. And this one you can see that the grades are differently categorized with respect to the rubrics. If you see over here, like for example, with this one, A plus grade, D grade, A grade, C plus, B plus, and B grades. And this classification is done by the needs-based classifier data analysis. So what is our reflection on this one? The indicators of the performance measurement could describe the attitude, skills, behavior of the computer science students and how they are performing during their industry field training period. Secondly, the hierarchy performance of the student, using our framework, which is a SUNFIT, is analyzed in the table 10, which we already discussed, with respect to the attendance, with respect to the sustainability, how they sustain their grades and their performance, with respect to the rubrics, their GPA, with respect to the best rubrics they have done it, with respect to the average rubrics and the worst rubrics, and what are the different opportunities they get to understand and constantly improve their field training with the students. So there are some more outputs if you look at the rubrics level. So if you see over here, the rubrics here are for example, rubric 1 was highly achieved, while rubric 2 and 3 and 4, they were not that much properly achieved. Rest of the rubrics are being constant. If you see over here, these are properly achieved. See from here also we can see that the grades are even some students, they have A grades. If you see over here, the blue one, the blue color is the A grade, and still students from the A grades, they could not perform well in these 3 rubrics. So this is the one of the interesting output from this our research. And basically rubrics measurement is across through different like courses of computer sciences, which is like introduction to computer, fundamental programmings, and principle of management, OB, organizational behavior, project management, and senior project implementation. So by this way, we see over here that how the news base classifier they did it, and we also notified that the rubrics which are like best, it has been notified, which are average, it has been notified, and which are worst, it has also been notified with respect to the previous GPA, with respect to the current GPA, and with respect to the certification where they have certification or no, and with respect to the attendance. So usually Abbott is working on the important thing is continuous improvement. So we go for program educational objectives, which is called PEO, and then we look at the program outcomes overall. What is the program outcomes? We linked with the CLOs, which is a course learning outcome, and these CLOs are linked with assessment rubrics. Assessment means like quiz, assignments, projects, and all these things, and then it goes to the continuous improvement. So this is a very important life cycle for in the teaching and learning phase. So recommendation for this one is that performance comparison of the students of the field training course against the PEO and SO and PI. Second thing is that how the comparison of faculty for field training against the Abbott. So how the Abbott is linked with the faculty, and performance comparison of the field training courses through formative course mapping, which is more qualitative with on the side of a trainer side, and with the summative course assessment with respect to the teacher side. And then the last thing is performance comparison program against the self-study report. So how we can checklist with self-study reports. So these were like 4 outcomes which we got it from this research. So thank you very much, and see you in the next discussion on the second paper.